Okay, so let's go through the homework problems, numbers 1 through 5, on page 377. Now, each of these problems was using the same equation, the ideal gas equation. You were just solving for different things. Some of the problems you were solving for pressures, some volume, some moles, some temperature. So let's start with number 1. It says, what pressure is exerted by 0.622 moles of a gas contained in 9.22 decimeters cubed vessel at 16 Celsius? So we're solving for pressure. 1 point to write the equation. 1 point to do the algebra. So I'm solving for pressure. My volume is 9.22 decimeters cubed. My temperature is 16 degrees Celsius, and my volume, or not volume, my moles is 6.22 moles. So my temperature must always be in Kelvin.
Is that for, that's for every single problem?
Every single problem, temperature must be in Kelvin.
Oh wait, it doesn't have to be in Kelvin for like Charles' law, right?
It has to be in Kelvin for everything.
Oh, so I feel like sometimes we do it when we don't do Kelvin. We just-
Always in Kelvin.
Yeah, we did do that though. Like on the lab for one problem we did.
Oh, we graphed in Celsius, but we didn't do a calculation in Celsius. When you're reading off the vapor pressure, you read the vapor pressure off in Celsius. That's just reading off a table. When reading off this table, the temperature's in Celsius. But any calculation is in Kelvin. Our volume must be in liters because the gas constant is in liters. But as you know, a decimeter cubed is a liter. So all I got to do is just change that to liters because a decimeter cubed is a liter. So 1 point for writing down everything you know. We do this to help you identify which equation. So you got volume, temperature, moles. The only equation that's got P, V, T, and N is the ideal gas equation. Then I do my algebra. That's worth 1 point. Then I plug the numbers in.
Where do you get the N from?
Then was given in the problem.
Okay. And R is the constant.
Constant. And then times the temperature, which is 289. Divided by my volume, which is 9.22 liters. Moles cancel, Kelvins cancel, liters cancel. The only unit I'm left with there, Allison, is kPAs.
So in this problem, that's kind of how you can check to make sure you get everything in the right.
You bet, because pressure is measured in kPAs. And I end up with 162 kPAs. That's the pressure. Number 2. Well, any questions on number 1 before?
169 or 162?
I got 162.
Oh, it's just 162.
So any questions on number 1? Number 2, same equation. What are they asking us to solve for? They want us to find moles there, Curtis. They tell us my volume is 486 cubic centimeters. My temperature is 11 Celsius. My pressure is 66.7 kPa. So right away I know, Sarah, that I got to convert my temperature to Kelvin. R is 8.31 liters kPa, mole Kelvin. So how do I get my volume into liters?
It's the same thing.
Decimeters cubed is the same thing.
Oh.
Tricky, tricky. 1 liter is 1,000 cubic centimeters. 1 decimeter cubed is 1 liter. So this one, since they gave it to you in cubic centimeters, we have to divide by 1,000. So that equals 0.486 liters. So now we have everything we need. All we have to do is solve for n. Again, on the test, you need to be explicit. You need to show all your work. So PV over RT is equal to N. So pressure is 66.7 kPa times my volume, 0.486 liters, divided by R, times temperature. So when I do this, I get 0.0137 moles with 3 sig figs. I got the unit on there, Rachel. That's half a point. Got my sig figs, that's half a point. Now these problems, like I said, it's been a while since we've had a math test. Watching me do it is of limited value. You have to do these problems. It's like riding a bike. You cannot learn how to ride a bike by watching somebody else. Impossible. You have to do it. If you're not doing the homework, you're going to crash and burn on the test. I've been teaching long enough to know, if you don't do these homework problems and just watch me do them, you will crash and burn on the test. So, just looking around the room here, if you didn't do these things, then go home tonight and pick some more problems and do them. Number 3, let's see, 3, 4, 5. Okay, let's do 3 just for funsies. Same equation, PV equals nRT. You give us the moles, give us the T.
You didn't write moles.
You don't normally write moles.
Oh.
P is 99.1. V we're trying to find.
Why do you not need units for moles?
Oh, I see what you said. I'm sorry, I
What do you
got
think I
confused.
meant?
I thought you meant I didn't write out the word mole for N. Yes,
Oh.
you do need to write, you do need to put a unit there. Thank you, Natalie. Now, why do I do this every single time I do a problem?
You know what
'Cause
to
it-
solve for.
It helps you pick out the right equation. Because if you have, the only equation that's got N, T, P, and V in it is the ideal gas equation. If you write out everything, John, and you have this, if you have T1, a V1, a T2, and a V2, then you're going to use Charles's law. if you write out the information and you see this, then you're going to use boils. So by writing out the information, it helps you pick the equation. And so when people say, I don't know where to start by writing down the information. It will help. Okay, let's solve for V. And 0.684 moles times R times temperature divided by my pressure. I'm going to have 3 sig figs. And I get a volume of 16.2. What are the units? Well, moles cancel with moles, kPa, kPa, Kelvin, Kelvin. The only units left are liters.
Or you put decimeters cubed.
The decimeter cubed is a liter, so it works. It's fine. So number 4 and 5 are just the same thing.
Can you tell us the answer for them if we're not gonna go through it?
The answers are in the back of the book, but I'll tell them to you anyhow. The answer to number 4 is negative 187 Celsius, or in Kelvin that would be 86 Kelvin. So negative 187 Celsius or 86 Kelvin. And number 5 is 277 kPa. Alrighty.